This one's who? Vishal? Okay. Okay. Fine. What we'll do is we'll go through the statistics. I made the PPT ready. Okay. Give me one moment. I should have some more content on PPT. My drive, training statistics, PDF. Okay. Let me. Okay, so we'll have just a definitions, I mean the basics today. Okay, so from Monday we'll continue, and I want you guys to do your practice tomorrow and on weekends. Okay, so that visualization is very important, because as you go along with the other tools like BI tools, business intelligence tool like Microsoft Power BI or Tableau, right, you will not understand anything until unless you have a hands-on. And also I'll give you one homework for weekend. Okay, so whatever the visualization we have done on tips data, and the other one we picked, I think, iris. Okay, so from that C1 library I want you to pick up something and then get going with the same practice. Okay, same whatever I've done, you have to do it with a different library. Okay, sorry, different data set, not library, sorry. Okay, so I'll give you at the end. So we'll get started with the basics. Okay, today we're going to do only the basics. Okay, so we're going to understand what is statistics. So statistics plays an important role, okay, in data science, because you're gonna borrow all the concept, methods of statistics in data science. Okay, like mean, mode, median, standard deviation. Okay, there are a lot other like probability. Okay, so data science is about probability. Okay, predictive. Okay, when something gonna occur, right? So there are some concepts that will go through it. And also see, statistics and all I cannot do it in the 5 sessions. Okay, only thing is you should be knowing the basics of statistics. Okay, and also after this training I'll share you a link, a very good content on statistics from right from basics. Okay, when I say basics, baby steps. Okay, so you will have ample session on what do you call hands-on practice, how the sampling is done. Okay, how the data is collected, how it is interpreted. Okay, all those concepts are covered in that video. Okay, it's a lengthy, I think 4 hours video which I have bookmarked for you guys. I'll share it after this, so we can just go through it. Okay, so tomorrow 1 hour, Saturday 1 hour, and Sunday 2 hour. Okay, like that you can finish. You have to keep a target for yourself to finishing all this activity, else it will just go away. You will not understand anything. Okay, so whatever the steps I am teaching, nobody will teach you, because I am going through very basics. Okay, so statistics. So what is statistics? Okay. So if you ask me the definition of statistics, it's a science. Okay. Statistics is a science of what? Collecting. Okay. Collecting what? Data. Raw data. Okay. How? You can collect through sampling. Okay, you have 100 people standing in front of you. Okay, I'll ask you to pick 10 people and ask what is their favorite TV show. What you'll do is you'll pick red, blue, or whatever the dresses they are wearing. You'll ask them to classify them, okay, in a group A, B, C, and then you'll pick two, 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 like that, and then you will start your sampling process, right? So statistics is a science of collecting, analyzing, okay, interpreting, okay, and lastly you will present the data. That is your last step, presenting data. Okay, so it's foundational, is used for data driven decision making. Okay, Okay, so this is the language of data. Okay, same thing I said, collecting, analyzing, interpreting data to make informed decision. Nowadays, whatever the decision making that is happening, it's on based on data. Okay, so say for example, you are running a restaurant. Okay, and you have collected some feedback from customer. Okay, some customers said they didn't like some curry. Okay, so what you'll do? You will not go through it. Okay, so if you don't go through it and if you take your own gut feeling and if you take your own decision, right? No, I will still prepare that curry only. It will I mean you will make sure that whatever the curry you are preparing, right, it will uh, people will like it and you will sell at the end of the day, right? But what happens at the end of the time, end of the day, the curry doesn't go well. Okay, people don't order it and you are at loss. Whatever the money you have spent on making that particular product or curry, whatever, right? It doesn't, you cannot sell it and you are at a loss. Okay, so when you have a data, okay, on a feedback. So last week people said this curry was not good. It has some smell or it has some foul smell or whatever. Okay, or the consistency was not good. Okay, so when you take this feedback and work on it, okay, and go back and give the feedback to your head chef or whoever the chef is there in your kitchen, right? Cloud kitchen or whatever. Okay, you tell them this is the feedback we got, so you have to work on this. Okay, when he work on it and he come up with a unique idea, okay, improvised version of the curry, right? And then when you give a sample to customer, same if they show up again, the old customers, give them a sample and see, okay, if they appreciate the hard work, okay, that you and your team are doing, right? Definitely it's a positive sign for you guys, right? So everybody does this nowadays. Okay, so if you take any decision based on the data that you have collected, okay, and interpreted, analyzed, okay, and then you took a decision, definitely you will not see any loss. That is the, I mean, even if you see the banks, okay, the repo rate that keeps on going up and down, right? All this data they collect from a lot of a lot of sources, right? And they give the prediction. So next year or next month, the repo rate gonna dip. Okay, based on the condition, current condition also they'll predict. So all all that they are doing is data driven decision making. Okay, so data driven decision making without a solid statistical foundation, data insight can be misleading, okay, or incomplete. Okay, for instance, predicting customer behavior, measuring product performance, and testing new features all rely heavily on statistical method to ensure accuracy and reliability. Even we do it in our company, in my company, I do that even today. Okay, and what is the role of statistics in data science? Okay, so like I said, it relies heavily on statistical methods. Okay, and what methods I can say is hypothesis testing. Okay, is a crucial for understanding patterns and drawing meaningful conclusion from large data set. Okay, now we'll see at basic statistical concepts. Okay, so like I said, this is the definition on extreme left. So it is the process of collecting, organizing, analyzing, and interpreting. Okay, and presenting data to reveal meaningful patterns and insights. Okay, when you have a data, right, you can bring out a lot of insights. But if you know the methods, how to do that, you can do and bring all those hidden insights. Okay, And see, in statistics we have two type of, I think actually three type of, okay, descriptive, inferential, and prescriptive. Okay, prescriptive is where you will give the prescription, just like a doctor, right? So you go to the doctor and you say, I have a fever, I have a body pain. He'll give some medicine. Okay, you go and try it out at home. Okay, and he'll say, you come after 2 or 3 days. Now what happens is, after 2 3 days, if it works well, if doesn't work, again you will show up the doctor and ask him, still I'm not recovered, what to do. Okay, he'll prescribe something else. Okay, so in statistics also we have prescriptive statistics. Okay, descriptive, okay, with the basic that we can do, basic methods, or features of statistics we can uh, include here in the descriptive. And inferential is something where you do the prediction, okay, or generalization, okay, about the larger population. Okay, you have to keep that in mind, larger population. This allowed us to draw conclusion beyond the observed data, like forecasting, market trends and all that. Okay, weather forecast also you can predict based on the data if you have. So they will compare whether it happened last year also same time, this flood has occurred in so and so region. Okay, they will read all those data for 10 years. Okay, and they will come out with their prediction. So it all depends on the data. Okay, historical data. So historical data plays an important role in your decision making. So now we'll understand what is population and sample. Okay, so everybody knows population and sample. Okay, so I'll just go through it. So the population means the entire group of interest, or uh, uh, I can say people. Okay, you are doing some research. So for example, you are introducing some cosmetic product. Okay, what you will do is you will open a stall in a big mall. Okay, and then you will give some samples. Okay, go please try it out, and this is the app where you can give the survey. Okay, how is this product, okay, whether it is beneficial or not. Okay, are you seeing any uh, uh, allergy after applying, okay, allergy symptoms after applying the cosmetic and all. Okay, so the population means the entire group of interest. Okay, and a sample is a subset of population. Okay, and that is used for analysis. Population is, say for example, I want to do the analysis for last year. Okay, now what I'll do is I'll take this last year as a entire population. Okay, so last year means what? Jan to December 2024. That is my data set. Okay, so whatever the tickets that we have received throughout 12 months, I'll pick, that is my entire population. Okay, now if I want to derive a sample from that entire population, what I can do is I can bifurcate by month wise or quarterly, half yearly. Okay, so these concepts should, you should understand all these things. Okay, sampling, sample, population and sample. Population's entire 100%, sample is part of it. Okay, now we know variables also we learned, right? So variable, what is variable? Variable can be categorical. Okay, example, uh, 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 a categorical variable is something like color. Okay, so you have a column called color, you have red, blue, green, yellow. Okay, so those are all categorical data. Okay, and numerical, you know, right? So age, if there is a column called age, income, these are all, these are all goes with numbers. Okay, so descriptive, if you ask me, descriptive versus inferential statistics. Okay, so descriptive statistics, what it does is it summarizes and present data. Okay, example, like I said, basics of statistics, which is mean, median and all that. Okay, whereas inferential statistics draw conclusion. Okay, now here the difference descriptive versus inferential is descriptive statistics summarize and present data. That's it. Summarize and present data. Example, median or mean. Mean, you know, everybody knows average, right? So you can give an average on a weekly basis. This is the average sales we are getting. Okay, so you can update your management. This is the sales we are getting on a weekly basis or monthly basis or quarterly basis average. Okay, whereas inferential statistics draw conclusion about population based on sample data. Okay, based on sample data. So it what it does, it draws conclusion, means prediction. Simple. Okay, and these two approaches, descriptive and inferential statistics, are very essential for any data analysis task that you carry out. Okay, let me move. Okay, yeah, so understanding data types. Okay, so again we are just brushing up the data types. Okay, qualitative, quantitative. Okay, so quantitative and qualitative data. Okay, quantitative is something numeric values that can be measured. Example, height, okay, in centimeter, temperature in degrees, or the number of items sold. Okay, just now I gave you some example, right? Variables that we have already learned in our Python basics. Okay, qualitative is something to do with categories. Okay, labels that describe attributes. Okay, for example, customer, gender, male or female, product type, electronics, apparel, or country of origin. Okay, now this is very important, measurement scale. Okay, nominal. Okay, so you will get to know all these things in statistics. Okay, nominal, ordinal, interval, ratio. Okay, so categories without inherent order. Okay, like blood type, A B O positive and all that. Okay, so this is a nominal type of data. Ordinal, categories with a meaningful order. Okay, so satisfaction rating. Okay, so if you see ordinal, I can give you one is the survey that we get after you order your food from Swiggy, right? Once the person delivery boy delivers your package at home, immediately you will see there is a survey, right? They'll ask you to fill in that survey and rate that agent, Swiggy, and the order. Okay. So whatever the data that uses scale, like 1 to 5 or 1 to 10 or whatever. Okay. So when you have something for categories, okay, with a meaningful order, okay, like a survey and all, we call that as a ordinal data type. Okay, and this one is interval, ordered data with equal intervals but not true zero. Okay, this is very important. In interval, not sorry, but no true zero, 0 point. Okay, temperature. Okay, so temperature in Celsius, where 0 degree doesn't mean no temperature, zero has some impact, right? Chill, very cold, or I mean when you are in some location where they get snow and all, right? So the temperature goes minus. Okay, so beyond zero, which is -1, -2. Okay, so here zero has a point here in interval. Okay, for temperature. Okay, I have a age column. In age, can I put zero? No, doesn't make any sense, right? So it starts by 1 year or months. Okay, age of a newborn baby, 6 months, 3 months, 4 months, and then it will gradually increase to 1 year, 2 year, 3 year, like that. Okay, and ratio. Ratio is ordered data with equal intervals. Okay, and a true 0 point. Okay, weight in kilograms, and the other one is income in dollar. Okay. Now we'll understand measure of central tendency. Okay. So what does this measure of central tendency means is finding the center. Okay. So I think during your academics, I think when you are in ninth or 10th, you have this all these concepts added in your academics, statistics, basic statistics and all, right? So mean, mode, median. Okay. So what is mean? Okay. So in simple term, the mean is the sum of all values. Okay, divided by the number of values. Example, say for example, average salary figure gives an overview of performance trend. Okay, so you have a salary, you take an average of it. Okay, and you can see what is the average salary that you are getting on a monthly basis. Okay, by 12. Okay, you take your salary, sum it up. Okay, 12 months, and then you divide. Okay, now what is median? Median is the middle value. Okay, when data is in a ordered form. Okay, okay, so median value when data is sorted. Okay, or either in ascending or descending order. Okay, less affected by extreme value than the mean. So I have given here some examples. Mode. Mode is repeated. Okay, the value that appears most frequently. Say for example, I have a column called age for a class 4 or class 10. Okay, 10th class student age is there. Okay, so age is 16 years. Okay, 17 years, like 35 students are there. Okay, and 16, 17 are repeated multiple times. Okay, so now what is a mode? Okay, first what I'll do is I'll sort the data in a order. Okay, I'll sort the data in a proper order, and then what I will do is I'll see which data points or value are appearing most frequently. Okay, so a data can have one mode, multiple modes, or no mode also. Okay, so here I have written the condition. Okay, here I have written a condition. Okay, now example you can see for student test score. Okay, so these are the student test score. Okay, 170, 75, 80, 85, 90. Okay, some numbers are there. Okay, scores, test scores, numbers are there. Okay, now what is the mean from this? What you'll do is you'll sum up divided by 5, so you get 80. Okay, same thing, sum by 5. Okay, what is the mid value here? You sort from here or here, 80 will fall here only. Okay, so 80 is your median, mid value, and mode is none because all are unique here. 90, 85, 80. If 80 is repeated again here instead of 85, 80 is repeated, then we say our mode is 80. Okay, all values are unique here. That's the reason. If you see the definition, it could be a mode, or it cannot multiple mode, or one mode, or no mode. Okay, and I can give one more example is same thing. Yeah, student only is a good example here. Okay, so this student example is very good. So this course, when you relate with mean, median, and mode, you will get some idea. Okay, so we'll do some hands-on hands-on also with the code, with the sample code and all. Okay, and then you will get some idea. Okay, and if you see here, why this is called measure of central tendency, finding the center value. Okay, now how see after finding the center value, what is next? Okay, you have to it's case by case. Okay, it's case by case. After getting the center value, what is next? Okay, you have to you have to analyze your data, and based on that also you can take some decision. Okay, so this one, next one is measure of dispersion. Okay, so dispersion means understanding the spread. If you remember yesterday, yeah, day before yesterday, when we were doing this Matplotlib, I was showing some visualization where you have this bar charts, and on top of this there is a line drawn, some similar to something like this, like a bell curve, right? Okay, so we called it as measure of dispersion. Okay, measures of dispersion. Okay, and what it helps is understand the spread, how your data is spread, okay, on a chart. Okay, now if you see the definition, okay, it measures how spread out that data points are from the central value. For example, this is just right now, here there is no line. Okay, if this is your central line, okay, and you can see if your data is equally distributed on both sides, right and left, okay, okay, then uh, uh, then it helps you to take your decision. Okay, if it is right skew or left skew, then you have to work on your data to bring that into a proper spread, and then you will start working on analysis. Okay, and it's a important as central tendency for complete understanding of a data set. Okay, so what are the measure of dispersion are there? Similarly, like if you see here, measure of central tendency, we have mean, median, and mode, right? Similarly, here we have range, variance, and standard deviation. Okay, so what is range? A difference between the maximum and minimum value. Say for example, you have the minimum age in a class is say in 10th class, okay, 16. Okay, max is 18. Okay, just giving an example, a hypothetical example. Okay, or height of a student in engineering. Okay, so hypothetically it will be like 5 feet 6 inch. Okay, roughly I'm giving a guess, 5 feet, or take 5 feet to 6. So now here, what is the range here? 5 is the least and max is 6. That's your range. Okay, max, min. Okay, now what is variance? Variance in simple term, difference. Simple. The average of the squared difference from the mean. Okay, so the square root of a variance, sorry, the average of the squared differences from the mean. One minute, guys, I was just getting one call. Okay, sorry. Okay, so variance, I was telling, the average of the square difference from the mean. Okay, for example, this is your mean. Okay, this is your mean. Okay, the average of squared difference from the mean. Okay, so when we do this hands-on, right? So we have some hands-on session with Python. Okay, so we will use all these statistical formulae, okay, with our data, and then I'll show you all those examples. Okay, right now it's just a theory right now today. Okay, just a brush up, and from next week we're gonna do our practice hands-on. Okay, so tomorrow we don't have class, like as usual. Friday no classes, so you can practice and just brush up whatever we have learned in visualization, Matplotlib and Seaborn. Okay, if you don't practice, you'll not get that hands-on. Okay, coming back to our topic, standard deviation. Okay, now what is the standard deviation formula? Okay, it says the square root of variance, whatever the variance you're gonna pick up from your data points, right? You square root. Okay, the square root of the variance provides a measure of spread in the original unit of the data. Okay, so you'll not understand by this definition, but when you do, and when you have a data points, right, real-time data, and then when you create derive at the standard deviation, okay, and it gives you some points. Okay, what does that mean? Okay, how to act on it, on the data, okay, and how to take a decision, basically decision. I'll take one sample sales data, and I'll help you out how this range, variance, and standard deviation helps in finding the hidden insight. Okay. Likewise, you can use it in another field also. See, all the statistical methods that we are learning, right? So it all acts on quantitative data. Okay, not on qualitative. Okay, quantitative is numeric data. Okay, so as long as you have a good numeric data, you can make use of it. Okay, uh, what else? Okay, probability. Okay, so I'm just going through the definition right now, but there are a lot in probability also. We cannot cover in 1 week or 2 week. Okay, it's a huge topics. Okay, so I'll share those videos. Just go through it. You have to just refresh. Okay, probability also we do it on a daily basis. What is the probability that you are standing at a bus station or train, metro, and what is the probability train will come on a in that sharp time or 9 a.m., right? You do that probability, right? Sometimes. Okay, and what is the probability in cricket match that India will win with Pakistan? Okay, so based on the data that we have, right, previous data, we do the analysis, we do the probability analysis on the historical data, then you can predict. Okay, sometimes it might come 50-50. Okay, 50-50 also I've seen. Okay, some of the projects that I've done 50-50, you don't know whether it will happen, the event will happen or no. You can tell, I mean, you have to infer in such a way that if you are not sure, you have to say uh, it might happen or it might not happen also. Okay, you have to be very open whenever you are giving your inference or any decision making on anything. Okay, so probability means how likely an event is to occur. Okay, famous is coin flip. Okay, so we used to do coin flip when we were playing a cricket match or whatever match, right? So we used to flip a coin and we'll pick head or tails. What is the probability? Okay, if you do 10 times, if you flip it 100 times, you would expect around 50 heads. Okay, that is a probability. Okay, and 50 times tails. Okay, so it ranges from 0 to 1. Okay, impossible to certain. Okay, and understanding probability is fundamental for making predictions. Okay, and assessing risk. Okay, so assessing risk in data science. Okay, now you understand where probability comes into picture. Okay, sales. Okay, you are launching a new product. Okay, say XYZ is a product name, and you want to I mean, your management share some data and some survey and ask you to work on the data uh, and come out with some analysis whether should we introduce this new product or not. Okay, though you have I mean, you have a product in a similar segment, but you want to innovate something and come out to make more profit for company, right? So you have that data points, you will pick up and you will give your inference that based on your result, you might say yes, you might say no, or you'll say we need some more data to play around and take a decision. Okay, you have to be very frank with your stakeholders, right? If you need more data to support your findings, you have to tell them. Okay, so what is probability distribution? Okay, these describes on how data value are spread. Same thing here. Okay, If you master this, right, the spread of data, I'm telling you, rest all, it will be like cakewalk. You will understand quickly. Okay. Okay. This describes how data values are spread and the likelihood of observing particular outcome. Okay. The normal distribution bell curve. Okay. Now, whatever you see here, this is called a bell curve. And this line that you see here, right, it never touches this x-axis. Okay. It will be close to it, but it will never touch. Okay. So bell curve is one of the most common appearing in many natural phenomena. Okay. Clear, guys? Okay. So let me explain one more time. Probability is the measure of likelihood, okay, that an event will occur, ranging from 0 to 1. Okay. And it's essential for understanding randomness, okay, and uncertainty in data. Okay. So again, in probability, you have uh, conditional probability, which depends on the condition. Okay. So uh, uh, I mean, conditional probability is the probability of an event given that another event has already occurred. Okay. Some other event has already occurred, enabling modeling for dependencies. Okay. Yeah, modeling for dependency. And there are some, what are these independent and dependency? So in probability, you will have something called independent and dependency. Let me see if I have written all those things. No. Okay. So independence and dependency. Independent events do not affect, okay, see, independent events do not affect each other's probabilities, while dependent events identifies dependencies that is crucial for accuracy. Okay. Now, what is this independent and dependent? Okay. For example, dependent. Okay, I'll give you an example. Uh, One classic example is uh, house house fair. Okay. You are buying a house. Okay. You have a data. Okay. You are working for a real estate company. So okay, and real estate company wants to do some analysis on the data they have. Okay. Price prediction. Okay. And you have the column called location. Okay. There are some locations like in Hyderabad we have Banjara Hills, then we have Maradpalli and all. Okay. So these are all posh areas, right? And 3 BHK. Okay. How many rooms are there? 3 BHK. Okay. What is the SFT square feet of the entire plinth area is somewhere around 2000 SFT. Okay, square feet, which is 2000 square, which is very big, 3 BHK. Okay, now you the price you have to predict. Okay, now how will you predict the price? Okay, so location, area, sorry, location, size, number of rooms, number of amenities, number of parking. Okay, all these factors affect your pricing cost, right? So similarly, we call them as dependent values. Okay, dependent events. Okay, so I'm trying to explain this independent and dependent events. Okay, something is independent which doesn't depend on other values. Okay, so it takes is independent events that do not affect each other probabilities, whereas dependent always take the probability. Okay, now whatever the 3 BHK I just mentioned in Banjara Hills, it might cost 1 crore. Okay, same size, 2000 SFT, 3 BHK. Okay, you are getting a similar kind of amenities like swimming pool, kids play area, whatever. Okay, similar, like carbon copy. Okay, the price is 75 lakhs. Okay, why is that? Location, right? And or maybe branding, I don't know, maybe branding. Okay, branding by these guys, I mean the construction company. If it is constructed by Aparna or very Lodha or big builders, right? Obviously the prices affects, right? Even though if it is in very slum area, if Lodha builds, obviously the price will shoot up. Okay, so all these factor plays an important role. Okay, that is what I'm trying to explain here. Okay, now in probability we have something called distributions. Okay. Okay, now whatever you see here, this is a normal distribution. Okay, like a bell curve. Okay, normal distribution. Okay, now, if you see here, this is the shape is like a symmetric, okay, bell-shaped distribution, okay, and it is characterized by its mean and standard deviation, okay, and there is another one called binomial distribution, okay, and another one is Poisson distribution. POISSON. Okay, so these I am not including. See, the statistics is very fast. It's like a C. We cannot complete in one go. Okay, so I'm just picking up all those top content which is required for our analysis. Okay, and I'll share the PPT also. Sorry, not the PPT, the video. Okay, a very good video. I used to refer whenever I distract some statistical concepts, right? I just go through it at my free time to just pick up those content. Okay, and then I will try to apply in my this thing. Okay. So one is binomial distribution, okay, and what is this? It is the model, the number of success in a fixed number of independent trials, okay. Say for example, you are flipping a coin, right? You might have success or failure, simple, okay. And what is the Poisson distribution model? Number of events occurred, okay, in a fixed interval. Okay, number of events occurring in a fixed interval of time or space. Okay, for example, bad weather. Okay, due to bad weather, so all these events that are happening, right? Does it happen last year? Okay, does it happen before that? Okay, so if you have the data, you can tell next year what is going to be in 2026 based on this data. You will say yes, it's going to happen similar. Uh, Similar thing in next year, in the upcoming year 2026. So be careful. Okay. Okay, these are all the just a definition kind of thing, null hypothesis, then collect data, gather relevant data through experiments. Okay, how do you collect data? Okay, through experiments, survey, or observation. Okay, and hypothesis we do it, okay, in medical field they do it. Okay, whenever they release any new drug, right, they will test it with a sample, population sample. They'll pick up population sample, they will test this out and see whether the medicine is working or not. Okay, null hypothesis, okay, or alternative hypothesis, and which is denoted by H1 and H0, okay, which states there is a effect or difference, a new drug has a effect. So you have to there is a concept, okay, so we will pick up some data, and then we will apply all those things, and then we will do the inference. Okay, so calculate the p value. Okay, So what is the p-value indicates here? So when you do your statistics calculation, right, for hypothesis testing, you get a result called p-value. Okay. Say for example, some number. Okay. So what does it denote? It denotes the p-value is the probability of observing. Say for example, 0 to 100. Okay. So the probability result has come close to 70. Okay. So you can say 70% there is a chance of this event to occur. Okay. Or this medicine has some effect. Okay. So that is a calculation. Okay. So the p-value is the probability of observing the result as extreme as or more than extreme. Okay. So example is see here, testing if a new marketing campaign significantly increase sales. Okay. And then you can conclude and you increase the sales. Okay. HO means null hypothesis. Okay. No increase in sales. Okay. So whenever you are working on any task, right? For example, you are releasing some content. Okay. And what is the guarantee that I mean, in your project there are some 300 people are there. They will see that. Okay. So you have to I mean, you have to formulate this hypothesis. Okay, H0, nobody will watch, or some will watch. Okay, and everybody will watch. H1 is everybody will watch. Okay, and if your p-value is 0.05, which is 50%, we conclude the campaign was effective. Okay, so this is very important. P-value is less than 0.5. Okay, so we'll do some examples in the upcoming classes on statistics only. Okay, and then you'll get a good picture about all these things. Okay, so this, if you do 2-3 times right on a data, you will understand. Okay, and if the see make a decision. How do you make a decision? Here I have given. Okay, if the p-value is low, typically less than 0.05, then we reject the null hypothesis, the first one, HO. Okay, we reject that. If it is greater than that, then we accept this H1. Okay, we reject the null hypothesis, concluding there's a significant evidence for the alternative. Otherwise, we fail to reject HO. Okay, so whatever the data you have, age or whatever numbers, right? You will apply those formulae. Okay, the probability or hypothesis, whatever you want to do. Okay, you can write down. Okay, and also see, this is used, this hypothesis testing is used in telecom department. I mean, especially with the data team. Okay, they will predict the churn rate. Okay, churn rate, what is churn? Churn is people leaving your service. Okay, for example, you I mean, take an example in India. Airtel is a service provider, right? Internet, cellular, and all that. They have a lot of services. Okay, now what they do is they will do the hypothesis testing. Okay, they are introducing some new package. Okay, for mobile. Okay, so for example, the monthly charges are 100 rupees, unlimited call, incoming call, and daily 1 GB internet. Okay, and on top of it you are getting Amazon subscription with that 100 rupees. Okay, they are introducing to add more customer. Okay, now so you have some data. Okay, you've been asked to do the hypothesis testing. Okay, whether it will work or take it. So whatever the data that you will do the analysis, and the result, if it is coming less than 0.05, then we reject the null hypothesis. Okay, stating that people will I mean, say for example, you I mean, your null hypothesis HOE states that there is no effect or difference, no people will not join or not pick up this Airtel, they'll go to our rival. Okay, like Geo or other. Okay, and the H1 is state that there is a effect or difference. Okay, people will join. Okay, so if your number from the data comes less than 0.05, then we reject the null hypothesis. Okay, or in simple term, null is something no negative. Okay, and this is positive. This is how you have to write your summary. Okay, otherwise we fail to reject the HO. HO is null hypothesis. Okay, this is confidence interval. Okay, so why I've added all this thing is to understand the interval, how it goes, and also even if you draw a line here, the curve line, the we called it as a regression line. Okay, your data points and all we have to measure. See this one. Okay, so if you put a line here, whatever the data points that are near to that, okay, will have some correlation. Okay, so this is a correlation between this is a correlation could be observed between hours studied and exam scores. As one increases, so does the other. See, the line is straight. So this is a correlation. Okay, same thing. If you do marketing, if you spend more amount on marketing, definitely your sale will increase, right? So there are different ways of marketing. So you have to pick up which one, okay, with methods, okay, how, when you want to do a digital marketing, okay, or manual marketing or hoarding marketing, okay. So it all depends. So obviously, whenever you see, you have to do the analysis for everything. Correlation, there is something called correlation analysis. Okay, measure the strength and direction of linear relation. Linear means straight line, if there is a relation or not between two values. All these white dots and red dots in between you see, right? So there are two data point. Okay, some are hours studied. For daily I'm studying 4 hours in a day. Okay, and marks mine is increasing. Okay, so that is what we are trying to show here. The analysis. Okay, it ranges from -1 to +1. Okay, if it is 0, okay, indicating no linear regression. Okay, now 0 is at the bottom, you can see here 0, this line. Okay, so this is 0. Here 1 2 3 4 5, this is the scale. Okay, same thing here 1 2 3 4 5 6 7 8 9 10. Okay, if what it says is, if with 0 indicating no linear correlation, if my data points are here somewhere here, okay, there is no data, there is no correlation between those two features. Okay, if it is going like this straight line, then there is a relation. Okay, this is what we do. Okay, and the confidence interval CI means a range of values within which a true population parameter is expected to lie with a certain degree of confidence. Okay, so we call this as confidence intervals, 95% confidence interval. Okay, it provides a measure of precision for an estimate. Okay, see, right now definition I know you will not get clearly right now. Okay, but when you do this hands-on practice, right, each analysis, why we are taking that decision, why we are not taking that decision. So we will come back to this confidence interval, correlation I showed you yesterday also with a graph visualization that is called heat map. Okay, so heat map also gives you the good correlation. Okay, so next. Okay, so this is about your summary. Statistics is the bedrock for making sense of data and building robust predictive models. Okay, so all these models that you see in AI and other areas, right, these are all borrowed from statistics. Okay, all models. Okay, so how do you start the learning? Okay, so you can master data types. First, basics data types, summarizing data, measuring variability, understanding probability, conducting hypothesis testing. These are all important. Okay, so and how do you apply it? Apply this concept practically using Python, R, and real world data set. Okay, from we can pick it up from Kaggle and we can play around with those data to understand. Okay, there are some more uh, concept like central limit theorem, CLT. Okay, so that is, we don't use that often, but hypothesis, probability, these we use now and then. Okay, and what else? What else? We have something called in hypothesis testing, right? There are some concepts called t-test, uh, chi-square test, ANOVA test. Okay, so ANOVA. Okay, and also this ANOVA, I think using ANOVA you can do the using ANOVA you can do the this thing. What is that called? Trend analysis. Okay, these are all very useful, guys. Okay, so see, I'm not asking you to do learn everything, but see, if you practice out of this any one, right, you'll get that idea. Next time when you get something right, you will have to read some white papers, okay, which are available, or you can get a suggestion through Google also. Okay, I have a data set like this, I'm working on it, so which test will recommend for me to start with. Okay, so it will give all 10 steps. You have to do all those things. Okay, clear, guys? Okay, so what we'll do is now we don't have a time. We are on top of the hour, 9:40. So we'll end this. Okay, and from Monday, I'll take one more session theory. Okay, one more theory because there are some more concepts are there. Okay, so I'm going to put everything whatever we have learned here, right? I'll put everything in my Jupyter notebook. The documentation part I'll keep it ready for Monday, and then we'll do a hands-on. Okay, hands-on with mean, then median, standard deviation. Okay, mean, mode, median, standard deviation, then variance, range. Okay, we'll just play around, guys. Okay, so then you will understand what is how statistics helping in solving problems. Okay, if everybody is okay, we will end this session. Okay, you can share the recording later on, Saib. Okay. Chalo guys, I'll close this session, and please practice, and I'm gonna send the link of YouTube